This is problem number 3A from the exam, and it said find a series for the log of 2x plus 1, find the interval of convergence, and then find a series expression for log 2. So the key ideas I'm going to use are this and this, which we've seen before. So the question is, what equals this? Well, I'm going to try that, so we'll see what happens, and I'm going to adjust if I need be. So I do this, and I'm going to use a w since I've already used a 2 up here. So that's going to be 1 plus 2x dw is equal to tx, 2dx. So this is going to be 1 over u dx. Now I have to solve for dx. That's going to be dw over 2. I think you might see what's going to happen. That's going to be equal to 1/2 natural log of w equals 1/2 natural log of 2x plus 1 plus c. But I have the half there. But what I want is just that, so I have to multiply everything by 2. So I go, therefore, 2 natural log 1 over w, 1 plus 2x. Here. So 2, 1 plus 2x dx, which is this, equals the log of 2x plus 1 or 1 plus 2x, however you like to look at it. And so, plus the constant. So then I need to turn this into a series and multiply it by 2 to get my integral. So I'm going to get, okay, the integral of 2 times 1 over 1 minus u. So I'm going to get a minus 2x here. Dx is equal to the natural log of 2x plus 1 plus c. So I'm going to have to integrate this. So here we go. So I get integral 2, 1 minus 2x equals the integral of 2. This is a summation right there. Minus 2x to the k. This is going to be equal to 2. Let's clean it up a little bit. Minus 1 to the k, 2 to the k, x to the k. We're almost ready to go. I'm going to bring this inside. So I get integral k equals 0 to infinity, minus 1 to the k, 2 to the k plus 1, x to the k. So all this right here is going to equal this. So I get natural log of 2x plus 1 plus my constant is equal to this integral. But remember, you change the integral with the function. Sorry, this should be a dx here. Dx is everywhere, and dx here. Remember, when you integrate a sum, you just switch. So this is fairly routine to integrate. Minus 1 to the k, that's a constant. 2 to the k plus 1, that's a constant. Add 1 to the x, exponent of x, and then divide by the new exponent. So this is equal to this. So I'm going to continue that. Remember, I need to find the interval of convergence, so we'll continue up here. So I have summation minus 1 to the k, 2 to the k plus 1, x to the k plus 1 over k plus 1 equals natural log of 2x plus 1 plus c. Now to find out what the c is, I plug in 0 because I get over here, I get natural log of 2 times 0 plus 1 plus c equals 0. And then if I plug in 0 over here, I'm going to get the summation k equals 0 to infinity, minus 1 k, 2k plus 1 times 0 over k plus 1, and that's equal to 0. So I get, therefore, c is equal to 0. Okay, and we are done. Sorry, didn't get that there. Okay, so then I get natural log 2x plus 1 is equal to k equals 0 infinity minus 1, 2k plus 1, x to the k plus 1 over k plus 1. Okay, now, for what x's is this good for? So remember, this is valid for u less than 1 plus maybe u equal 1, absolute u equal 1. So my u was 2x. So I know it's valid for 2x less than 1. In other words, x less than 1 over 2, absolute, sorry. And it may be valid. We just don't know until we check, because to either for x equals plus 1/2 or minus 1/2. So we just have to plug in to find out. So I'm going to plug in x equals 1/2, and we're going to see if this series works. So that would be the natural log of 2 times 1/2 plus 1, which is my log 2. So this should work. Is the same as this. I plugged in a 1/2 here for x. Remember, x is 1/2. And I think you can see there's going to be some cancellations. So this is equal to this. And by the way, this will converge by the alternating series test. And how do I know that? Well, terms decrease. And the second this limit equals 0. So that's why this. So what I know is that this is the log, and I can plug in x equal 1 and I get convergence. And not only that, but it converges to natural log of 2, and I chase it around, and so this is what the natural log of 2 is over here. So I get, we'll continue, the natural log of 2 is equal to summation k equals 0, infinity minus 1 to the k over k plus 1. Okay. So now I have to test x equal minus 1/2, so I'll do that. So I plug in x equal minus 1/2 into the series, and I get natural log 2 minus 1/2 plus 1. That's natural log of 0, which is impossible, so my guess is the series will diverge, but let's see. To make sure, I plug in x equal minus 1/2. I get summation minus 1 to the k, minus 1 to the k plus 1, over 2 to the k plus 1, all over k plus 1. Let's do some cleaning up. I get minus 1 to the 2k plus 1. I add the exponents, and that's going to be all over 2 to the k plus 1. Sorry. I made a mistake. So we're going to do this one again. Okay, that happens. So I need to plug in x equal minus 1/2. And I have to plug it into this. And this is where I made the mistake. I have to look to see what my log series is. It's 2 to the k plus 1, which is what I forgot in the last one, times x to the k plus 1 all over k plus 1. Okay, so I plug in, remember we're trying to see if it converges or diverges there, so I plug in x equal 1/2, and so I get the log of 2 times minus 1/2 plus 1. That's 0. The log of 0 doesn't exist. It suggests this series will diverge, but let's see what happens. So we plug in x equal minus 1/2 for that all over k plus 1. And what I'm going to get is, here, I'll just do it here. I think we have enough room. and this is going to be 2 to the k plus 1 times minus 1 to the k plus 1 over 2 to the k plus 1, just distributing that exponent, all over k plus 1, cancels. Minus 1k, k plus 1 is 2k plus 1, that's always going to be negative, over k plus 1. This is going to be the negative p series, so let me write this out. I'm going to have minus 1 for k is equal to 0, minus 1/2 when k is equal to 1, minus 1/3, etc. And this is going to go off to minus infinity, so it diverges. So, summation, I'm sorry, that's a bad pun. To summarize, we get this series is equal to the natural log of 2x plus 1 for x less than or equal to 1/2, but strictly greater than that. And we get log 2 is natural log 2 times x is 1/2 plus 1, and we saw from above that that equals this thing right here, minus 1 over k plus 1. Okay, that's the answer.